Good afternoon, good morning. Today we're here to talk about electrical safety for affected employees. I want to talk about electrical shock occurs when a body comes in contact with a source of energy and becomes a part of the electrical circuit. Very little electricity is needed to cause serious injury or death. The typical household current is more than enough to kill someone. Effects of electrical shock. The severity of an electrical injury depends on several factors. The first factor being current. 1 amp is enough to cause death. In fact, death is possible at 50 milliamps or half of 1 amp. Likely at 1 amp, it's probable at 10 amps, and the typical household circuit is 15 amps. 2, moisture and resistance. Wet surfaces and skin are more conductive. A lower current received through a more conductive material is more likely to be fatal. 3, path. A shock travels through the body to the ground. If the shock travels through the heart or a vital organ, the shock is more likely to be fatal. And 4 is time. The longer the duration of the shock, the more serious the damage. All work-related injuries are considered serious and require an accident investigation when we're talking about electrical injuries. The full extent of an electrical injury may not be immediately apparent. So, when we're dealing with electricity, we're talking current, moisture and resistance, path and time. And now we're going to move on to who can handle electricity and who can't in relationship to maintenance, in relationship to fixing and troubleshooting problems in and about the mill. Everybody in the plant would be considered affected. They're in and around the electricity, you're around these boxes, you're around it in lockout, but you can never go beyond the electrical hazard barrier of danger zone. That means if you're not on the short list of authorized people, you would know if you were on it. That means you've been trained, you've been classroom trained and practical on the job trained. You understand the PPE for electrical hazard. You are on a very, very short list. We're talking about a list of 2 to 3 people. If you aren't on that list, you have no right and should never assume that you can deal with live electricity. Okay, this is a very dangerous thing. It will sneak up and attack you, and it's very important that we treat it as lethal as it is. We have to treat it with that level of intensity so that we prevent that. So authorized staff, if you don't know who they are, check with your supervisor and they will get you a list. But more importantly, if you have any questions, concerns in your area, we're going to talk about that in a minute when I focus over on this board. We're going to look at a few things that you may find in your work area in an effort to fix things before they become a problem or could hurt somebody. So what can you do to help? We're going to pan in on the board. Initially, we're going to take a peek at some of the issues that we might find. So we could see strain relief, which is where you see that the plug end here has pulled away from these wires. Inside of the strain relief, you'll see frayed wires. So if you see the outer coating of the wire rubbed off and that's a frayed wire, very possibly could be cause hazard. One of the most important pieces of this, and this could affect you at home as well, as there should be a ground terminal on this ground post on every plug, especially here in a commercial setting. You should have these. Just because it may not have it on an at-home tool doesn't mean that you're not exposed to the danger at home. Remembering the amount of amperage that could kill you is 0.1 or 0.2. Most of our household goods, like a hair dryer, they should have this prong as it's running a lot more amperage than 0.1 or 0.2 amps to run that. So this is something that we often see, that these get broken off and then that particular tool doesn't get pulled out of service and whoever's using it truly is exposed. Here you can see this switch just burned right up while it was out in the plant. We've just got it on the sample board as a reference point. We've got a 110 plug outlet that clearly is broken, got hit. On top of this, we call this a knockout. an electrical knockout. So you put your finger down in here, if there's live juice in there and you come in contact with something, especially the power or neutral side of this 110 outlet, you're very much exposed to closing the circuit, and you could be injured or killed. On this board, many people have seen these disconnect boxes. Want to talk specifically about this, is that it's very important that we not put our bodies in front of the disconnect box like such before we pull. We always want to pull the disconnect. One, we want to pull it quickly down, not too aggressive, but quickly, and we want to keep our face away from it, and you want to get it down so that that breaks through and kills the power there. Or when re-engaging it, again, quickly, firmly, making sure that switch is back engaged, but at the same time keeping ourselves as far away from it here. Electricity's going to blow this way, and I'm not exposed over here, not as exposed when I'm using those disconnects. Further down, we can see where this J-box, there's a few issues. It's gotten hit hard, so it's pushed in on the wires. The wires are sticking out. These are all things that if you're out in your area and you're working and you have your notepad, write these things down, get them to your supervisor or your safety personnel like a Rolando, Mike Lathrop, over in Premier, Eric Woolridge or Sergio, up in McConnellsville, Pat Buff, Jim McNamara, Derek Pangburn, John Wheeler. Those names come to mind, that we want to let these folks know that these problems are showing up so that we can get them fixed. Look at all the knockouts on this junction box that are gone. These are the things that we need to get fixed. So that pretty well covers the hazards as far as the electrical hazards that we have on our board here. The last example that's on your sheet, and Mike is going to demonstrate here. So we'll say that Mike, circumstantially, this is a live wire, and Mike's got his finger on that wire, and he's now being shocked. I should never go up and touch him where I'm now going to be the conductive piece of this circuit, and now he and I are both stuck together, and we're probably going to die together. What I should do is take something like a piece of wood, or first and foremost, I should look to eliminate the source. If it's close by, shut the source off, see if it releases him. If it's something that can happen quickly, remember, we're battling time. Time is of the essence. If he's a closed circuit and electricity is running through him, we've got very, very little time. So grab anything non-conductive, rubber, wood, and bounce him off of that, but make sure it's not you, or you become a part of the problem rather than the solution. That's all that I have as far as electrical safety. I hope everybody has a great day. Stay safe. Thank you.